We start our exploration with a map of the positions of all the galaxies that astronomers have measured within 120 million parsecs, or approximately 400 million light-years. The map is in supergalactic longitude and latitude, with the disk of the Milky Way galaxy noted here as the zone of obscuration, where we cannot see through to other galaxies at a slant through the center. Each of these colored dots is a single galaxy. The nearest galaxies are in dark blue and are found around the Virgo cluster to the right of center, or around the Fornax cluster in the lower left. One of the two most prominent filaments is the Pavo-Indus structure in light blue and yellow that can be followed from near the Virgo cluster across the disk of the Milky Way, rising to the left. The other prominent structure is the Perseus-Pisces filament in yellow and red, rising at a sharp angle on the left. Where do these galaxies lie in 3D? That's seen as we move galaxies from the flat 2D picture we had to a three-dimensional cube. The galaxies end up at their actual positions in the local universe. The Perseus-Pisces filament is the structure near the front of this view. The complexity of what we are seeing can be overwhelming, but we can start by having a closer look near where we live. We are approaching the Milky Way, our galaxy, which is represented by the blue dot. The scene is now centered on the Milky Way, with its nearby small galaxies, and the adjacent Andromeda galaxy also with its nearby small galaxies. Other nearby galaxy groups are also identified. We have good distance measurements for most of the galaxies within this picture. We are currently looking at a cube that is 6 million parsecs, or nearly 20 million light years on each side. By rotating the cube, we are able to see that most of the galaxies in this nearby space lie in a thin disk or plane. There is a very empty sector above this plane called the local void. We call this flattened disk of nearby galaxies the local sheet, and we see that it is a wall on the edge of the local void. We return to a top-down view of the local sheet, except we have zoomed out a little bit to also include the Virgo cluster. With this next picture, we zoom out to see a top-down view of a thin slice of the entire catalogue of galaxies we are looking at. The most striking feature is the crowding of galaxies running left to right from Hydra Centaurus through the Virgo cluster to Ursa Major cluster and beyond. Other interesting features include the Fornax cluster region, Perseus-Pisces, and the southern wall Pavo-Indus, and a slice through the Great Wall. We will rotate around and look at a different slice through the galaxies. This slice includes the Virgo and Fornax clusters, the local sheet and local void near the center. We see parts of the Great Wall on the right and the southern wall on the left. There are strikingly empty regions like the Hercules void and the Sculptor void. We rotate again and look at a thicker slice. This gives us an edge-on view of major components of the Centaurus-Hydra-Virgo supercluster complex. The structure seen in the top-down view that ran from Centaurus cluster through Virgo to Ursa Major now is seen to consist of several separate strands. The main features are the horizontal filament and the pronounced antler wall, which runs down from Centaurus cluster to Antler cluster and then turns horizontal in this view. Again, many voids are seen. The microscopium void in particular can be clearly seen. The scenes that have been shown so far give a higher impression of the importance of the local region than is seen in reality. We are aware of objects nearby that are unnoticed far away. It can be assumed that the distribution of galaxies, large and small, is roughly the same at all distances in the small patch of the universe we are considering. If we assume the universe is similar from where we are to the edge, then we can roughly guess how many small galaxies we can't see are near the big galaxies that we can see. If we do this, then the local region appears dramatically reduced in importance. The main structures we see are the Great Wall, the Perseus-Pisces filament with the southern wall. Pavo Indus is significant as well. We rotate to something like a top-down view. We see the importance of the Great Wall and the Hercules cluster region within it. The Perseus-Pisces filament is important, and we see its connection with the southern wall. The local supercluster is not so important. In the next series of images, we look at the central region of the supercluster complex that we live in. The Centaurus cluster seems to have a special place where 5 strands of galaxies are meeting. In this top-down view, galaxies in major clusters are coloured red. Otherwise, galaxies in the 5 different strands are giving distinct colours: green, pink, purple, orange, and blue. The blue strand splits into 2 branches as it crosses the zone of avoidance. The meeting of the 5 filaments into the Centaurus cluster is best seen if we slowly move around the cluster. There is a vertical wall of galaxies in this view that includes the Centaurus, Antler, and Virgo clusters. The local void is bordered by 2 of the strands from Centaurus. Now we are going to look at how galaxies move through space. The lines emerging from each galaxy dot are the directions in which each galaxy is moving and how fast. The longer the arrow, the faster it is moving. It takes a few assumptions and a couple of tricks to estimate the velocities, but we can do this quite reliably. In this view, we have replaced all of the individual lines by average lines of movement for all of the galaxies in that area. Higher density regions, where there are more galaxies, are shown in red, and voids where there are less galaxies are shown in blue. Take note of the importance of the region around the Centaurus cluster. Let us rotate again and consider another slice through the galaxies. We can see the wall of structure running from Centaurus and Antler through Virgo and Ursa Major. We look again at the velocity and movements of the galaxies. Again, we see the importance of the region around the Centaurus cluster. Finally, we take another view of the galaxies. In this slice, have a look at how the galaxies flow out from voids and the size of the local void. The local void is big, but we are not sure how big as its edge is further than we can measure accurate galaxy distances. We end with a three-dimensional view of the supergalactic equator.